there is a third form of a line. So let's recap. So we've talked about slope-intercept form of a line, which is y equals mx plus b. We just did point-slope form of a line, which is y equals m times x minus x1 plus y1, where we don't have the y-intercept. Instead, we have just another point. The third form of a line is called standard form. And in standard form, we don't have y solved for. It's ax plus by equals c. When we don't have the y being solved for, we also don't have a slope, right? These two had a slope. This one, the slope's not apparent. Now, one thing we can do with standard form is solve and get y by itself. But the other thing we can do is find intercepts. So we're going to plug in x equals 0 and y equals 0 to find the intercepts. That gives us another way to graph when you don't have the slope. All right. The other option, though, is putting it into y equals mx plus b form, doing the algebra to get y alone. But we're going to practice using intercepts and seeing how that works. All right, so an x-intercept is always y equals 0, and y-intercept always means x equals 0. And that's not just for lines, that's for any graph. It works for parabolas, it works for any kind of function we might encounter. All right, so if it says find x and y intercepts, we're going to start the x-intercept, we're going to plug in y equals 0. All right, so let's do that, x-intercept. So where y is, I put 0. 3 times 0 equals 6x plus 12. And then I just solve for x. 3 times 0 is 0. I'm going to go ahead and subtract 12 from both sides. So 0 minus 12 is negative 12 equals 6x. And then we divide both sides by 6. So that gives me x equals negative 2. Now we do want to write intercepts as points. So the intercept is the point negative 2 comma 0. All right, so hopefully that makes sense. It's just doing a little bit of algebra to get x alone. Y-intercepts. To find the y-intercept, we plug in x equals 0. So let's do that over here, y-intercept. So we're keeping y where it is and instead making the x be 0. So this is 3y equals 0 plus 12. So that's 3y equals 12. And then if I divide both sides by 3, I get y equals 4. Now remember, it's a point, so we need to write it as the point 0 comma 4. So those are our two intercepts. The x-intercept has an x value, but y is 0. And the y-intercept has x equals 0, and then the y is some other number. Okay, so let's try some more of these. Don't forget to express your intercepts as ordered pairs. That just means points because they are point. I should probably put an S on that. They're points, plural. All right, this is standard form of a line. We have a number times x plus a number times y equals some other number. We don't have y equals mx plus b. We could get it in that form, but there's no reason because they're asking for intercepts. All right, x-intercept means I plug in y equals 0. So that is 7x plus 14 times 0 equals 28. Now sometimes, and if if I helped you with this in Alex, I might have told you like, oh, well, for the x-intercept, you can just sort of ignore that y is there. I'm covering up with my pen here because multiplying by 0 makes this go away. So this is just 7x equals 28. When we're in standard form, it works where you can just sort of ignore the other variable. So what I'm seeing here is x equals 4. So that's the point 4, 0. Well, then the y-intercept, if I'm plugging in x equals 0, that's like ignoring x. So that would just be, like if we plug in 0 here, it'd just be 0 plus 14y equals 28. The x is gone, and then I just divide by 14, y equals 2, but we write it as the point 0, 2. So it's still plugging in 0, but maybe that's a quicker way to think about it. All right, let's try it that way this time. So x-intercept means y equals 0, so I'm ignoring y. It's gone. So that's just 2 times something is 36. 2x equals 36, divide by 2, x is 18. So the y-intercept is the point 18, 0. All right, if I ignore y over here, no wait, not ignore y, I'm trying to solve for y. Ignore x, get x out of here. Make sure that negative is still in front of the 9. Negative 9y equals 36, so I divide by negative 9 on both sides. So that makes y equal negative 4. So it's the point 0, negative 4. Cool. All right. Let's do some where we're having to graph these. So they are in standard form. And instead of solving for y, I'm just going to use intercepts. So for the x-intercept, we're ignoring y. Y is out of here. So I see negative x equals positive 4. If negative x equals positive 4, that means positive x is negative 4. So that's the point negative 4, 0. Or right here on the graph. Okay, let's do the y-intercept. For y-intercept, I let x equal 0. In other words, x is gone, so it's 2 times y equals 4. Well, that is just y equals 2, so it's the point 0, 2. So if we see a line in standard form, usually it's easier to use intercepts to graph it. Not that it would be that hard to like move x over and divide everything by 2, but you know, using intercepts is a good option too. All right, let's try another one. Let's see. For x-intercept, we plug in y equals 0 or ignore y. 2 times x equals 8. 2x equals 8 means x equals 4. So it's the point 4, 0. This is where x equals 4. For a y-intercept, we're plugging in x equals 0. So if x is gone, make sure the negative is still with that 4. Negative 4y equals positive 8. So y is negative 2. So it's the point 0, negative 2. Down here. And then we just connect these 2 points. Make sure it looks decent. Lovely.